Today we are going to cover section 6.5, exponential and logarithmic equations. So write down your title, your essential question, how do you solve exponential and logarithmic equations? Paste your cutout, and we'll start once you are ready. And pause it. So for a greater than 0, and we don't want a to be 1, remember that will be the base. The following properties are true for all x and y for which the log base a of x and log base a of y are defined. So as long as they are defined and they are not they're within the domain, then these properties apply. So we talked about the one-to-one property on section 6.2, where if you have the same base, that means that x is equal to y. And once again, the word if and only if, right? If x equal to y, then we can raise them to the same base and they'll be equal to each other. The log base a of x equal to the log base a of y. If they have the same log with the same base, and the base has to be exactly the same, that means that the x and the y has to be equal to each other. And we also talk about the inverse properties. If there is a base to an exponent with log base a, since they're inverses of each other, they cancel each other out, so we just have an x. In the same way it works whenever you have a log base a of a to the power of x, we can say that they're inverses of each other, so therefore they can cancel out, and they'll be equal to x. Now we do need to have to be careful. The domain of a logarithmic function generally does not include all real numbers, just like we discovered on section 6.4, or actually 6.3. So you should be sure to check for extraneous solutions of a logarithmic equation. So once again, we are going to end up with sometimes with extraneous solutions. So it is important that you check your answers every time we are working with the log function. So let's go through example number 1. Let's go and solve. There are two ways to think about this. I prefer to think about this as a base of x, and I just want you guys to think, okay, what is the opposite of a base? Opposite of a base is a log. So to get rid of the base 2, I'm going to use the inverse property. I'm going to take the inverse on both sides. The same way that if it's adding, you subtract on both sides. If it's multiplying, you divide on both sides. The opposite of a base is a log. I'm going to take the log on both sides. And the base should be 2. So therefore, the log base 2 and the 2 cancels out according to this property. So therefore, I have x is equal to the log base 2 of 10. Now, there's going to be times that they're going to be asking for the exact answer. So this will be your answer. There's going to be other times that they are going to ask you to approximate the value of x. So you can think about 2 to what exponent is 10. So therefore, x is approximately. And for that, we're going to use our calculator. Now, if you have an older calculator, then remember that you won't be able to type this in to the calculator. So therefore, what we need to do, we're going to have to do the change of base. So I'm going to go into my fraction bar, or I can just do parentheses. Log of 10 over log of 2. But most of the time I prefer to use my fraction bar, makes it a little easier to see. So log of 10 over the log of 2. So it'll be 3.32. Approximately 3. And you can give me 2 decimal places. On your homework, they'll ask you for, it varies from problem to problem. So just make sure that you are careful with how many decimal places you need. And also, whether you want an exact answer or you want an approximation. And if you do have an approximation, I do need to be able to see the approximation sign or symbol instead of the equal sign. And that's it. So solving logs and exponential functions are very easy. We have a log. I need to leave the x by itself. What is the opposite of a log? It's a base. Opposite of a base is a log. Opposite of a log is a base.
Just a sec.
Thank you.
I won't respond.
So therefore, the opposite of a log is a base. So I'll place a big 3. And I'll place a big 3. This method is called exponentiate. I'm going to exponentiate both sides, the left and the right. So therefore, I'm going to use my inverse property. It tells me that cancels, because it's the inverses of each other, that x equal to 9. 3 squared is 9, and that's an exact answer, and that is correct. Now, for this one, this is a log, so therefore, I do need to check for extraneous solutions. The only thing that we are concerned with logs is with the domain of the logarithm function. So I need to be able to take the log. I can go through the whole process and check if I need to. So I can check. Okay, so well, let me plug in a 9. Log base 3 of 9 equal to 2. Yes, 2 equal to 2. Right? 3 to the second power is 9. But the only thing that we actually are concerned is that the value of x, when you plug it in, it doesn't give you undefined. So can I take the log of a positive number? Yes. So that's it. We don't need to go through the entire check. We can just make sure that the value of x, when I plug it in, it's a number greater than 0. Cannot be 0 either. You cannot take the log of a 0. And we can refer back to your, when we graph logs, to notice that you don't get any values back due to the asymptote. Example number 2. Go and copy it down, pause it, and we'll start once you are ready. So I need to be able to solve. Notice that both x's are part of your exponent, and the only thing that we have on the left is a base e and a base e. So therefore, you can think about the one-to-one property, where they tell you that if they have the same base, those two should be equal to each other. Or you can think about the inverse property. It's okay. What is the inverse of a base? A log. So I can do log base e, log base e. But we usually don't do log base e, right? What do we use instead? Correct. We usually use ln, which is the same thing. So they cancel each other out. You have negative x squared equals 5x minus 6. So most of the time, whenever we have a same base, we just think that the exponents are equal to each other. And now I can solve it. So solve for x, pause it, see what you get, and then we can compare our answers. You got it? So at this point, you have solved it. So now I'm going to move my x squared to the left, make it equal to 0, because I want my x squared to be positive. So I have x squared plus 5x minus 6. Quadratic equation. Let's see if I can factor it. If not, I probably don't want to complete the square root because of the positive is a odd number. So if I can't factor it, I need to use the quadratic formula. Factors of x squared gives me x and x. Factors of 6 will be 3 and 2 or 6 and 5. 6 and 1. 6 and 1. So 6 and 1 different signs will be a positive. That's a negative. And now, since they're multiplying and they're equal to 0, my 0 property tells me that either x plus 6 equal to 0 or x minus 1 equal to 0. So therefore, x equal to negative 6 or x equal to 1. Now, we start with an exponential function. So there are no extraneous solutions when we're working with an exponential functions, only when we're working with logs. Letter B. Now, actually, let's check your answers. But in this case, we're going to check it graphically. Do you remember how to check? How can I check this to see if those two are the solutions graphically. Right, we can just go into Desmos, or you can use your graphing calculator as well, but Desmos makes it a little bit faster. I'll type in my first function, f of x equals e to the power of negative x to the power of 2. That is a graph. And also you guys start to get familiar with the different type of graphs that we can have. The ones that we actually don't get to graph by hand. To the power of 5x minus 6. So therefore, our solutions, let me zoom out. Oh, what? Oh, there. So our solution doesn't match. And of course, because DS did not type it incorrectly, minus 6. So again, so therefore, we're typing 5x minus 6, and then I go back and delete my 5x. So therefore, one solution is 1, and the other one should be negative 6, and you can see it here. So let me zoom in. Sometimes you have to zoom in because probably the x, the y-intercept is the same. Your x-intercept is the same. There, but it's hard to see it here. So one of the ways I can check and see, I can say, no, well, what's f at negative 6? Well, let me give them different names. G. And what is g at negative 6? And see if it gives you the same value. Notice that gives you the exact same value. The only thing that, because it's so close to the x-axis, it doesn't. I can zoom in and see if it does it for me. It's not working. But those are, if you can see, those are the true solutions. So one of them is 6, it's 1, and the other intersection is right here. It's not negative. It should be negative 6, as you guys can see here. But you get the point. Letter B. How can I solve this equation? So try to solve it. Go and pause it, solve it, and see what you get. You got it? So in this case, I want to get rid of my denominators. Remember, every time you have a fraction, you want to get rid of the fraction. So I'm going to multiply both sides by 1 minus 2e to the x power and 1 minus 2e to the x power. That will cancel out, so therefore I end up with 8 equals distributive property 2 minus 4e to the x power. And now I just want to be able to isolate the e to the x power. So move the 2 to the left, becomes a negative 6 equal to negative 4 e to the x power. Divide by negative 4. Divide by negative 4. So therefore e to the x is equal to 3 over 2. And now, how can I get rid of the base? The log base e, or we say the natural log. So therefore x is equal to the natural log of 3 over 2. And now I can get an exact answer, or I can type into my calculator and find the approximation. So in your homework, they'll go back and forth. You want to make sure that you give them both. When you do online, you have to type in either one or the other. So we type in natural log. I'm going to use my fraction bar. And 3 over 2, or 1.5. 0.41. Example number 3. So take the time to copy example number 3, and we'll start once you are ready. Go and pause it. So let's continue solving equations. So for letter A, we have a base of 2, and the x is the exponent. So in this case, we are very tempted to multiply the 3 times the 2. But because the 7x only belongs to the 2, the exponent belongs only to 2, and the exponent for the 3 is a 1, we cannot multiply those two numbers. So what should I do first? Correct. I should divide by 3 on both sides. So it's multiplying. We are going to divide. So the 3's cancel. So now I have 2 to the power of 7x equals 42 divided by 3 is 14. I need to get rid of a base. How can I get rid of a base? To get rid of a base, we're going to do the inverse, take the log on both sides. Now I need to get rid of the base 2, so I need to take the log base 2 on both sides. According to inverse property, that will cancel out, so therefore 7x equals log base 2 of 14. And now I need to get rid of the 7. It's multiplying, so the inverse operation is to divide by 7 on both sides. That 7 cancels, so therefore x equals. Now be careful. We cannot divide 14 divided by 7. We need to be able to evaluate this expression and then divide by 7. But many times they're going to ask you for an exact answer. So that we're going to leave it as log base 2 of 14 divided by 7. And that will be the exact answer. Now, if we need to be able to approximate, we are going to use our calculator. And I'm going to use my fraction bar. My calculator does have the log with a different base. So therefore when I select number, I can go down and then press enter, I can press number 5. So base 2 of 14 divided by 7. Therefore, x is approximately, I need 2 decimal places, so it'll be 0.54. And can we check that online? Can we check that through a graphing calculator? So let's use decimals to check our answers. Can you use decimals and see what you get? Go and pause it. Check your answer using decimals or a graphing calculator. You got it? Correct. So in this case, I'm going to use f of x equals 3 to the power of 2 to 3 times 2 to the power of 7x. Move to the right, close it. That's my first function. My second function is g of x. I must say g of x equals 42. And therefore, I can go up, but instead I'm going to adjust my window. It'll be from -5 to, it's 42, that's a horizontal line, so I'm going to set to 50. Oh, not my x, I need my y value, correct? So let me leave that how it was. I want my y value to be from -5 to 50. That way I can see the entire graph. Because I know that is 42 is a horizontal line of 42. And I can see that my intersection is correct. Example number 2. And remember that if you don't have that notation, you can actually just go through a process and just say, okay, I'm going to use the change of base for this part. So with the log of 14 divided by the log of 2. And I can divide that by 7. It gives you the same answer. Letter B, I need to solve for t. So therefore, I need to get rid of the 2, the -6, the 3, the 2, the -4. What should I do first? So try it, go and pause it, try it, and then we can compare our answers. So first, move the 4 to the right, becomes say +4. So that gives you 15. So we have 2 times 3 to the power of 2t minus 6. Next, I need to get rid of the 2. So I'm going to divide by 2 on both sides. To end up with 3 to the power of 2t minus 6 equals 15 divided by 2. I can leave it as 15 divided by 2, but I'm going to leave it as a decimal as 7.5. Now I can get rid of the base. The opposite of a base is a log. I'm going to take the log on both sides. Log base 3 because I want the base to cancel. So therefore that cancels out. And I have 2t minus 6 equal to the log base 3 of 7.5. And now I can leave the t by itself. Move the 6 to the right, becomes a positive 6. Divide by 2. When I divide by 2, I can leave it as this format, as my exact answer. But instead, I want to divide each of the terms by 2. So therefore, it will be the log base 3 of 7.5 divided by 2 plus 3. Sometimes you'll see this as a different form. There's a coefficient of 1. Do you agree? So therefore, t equals 1/2 the log base 3 of 7.5 plus 3. So you probably will see it as in this form. And notice that's a little nicer than this form, correct? So this will be the preferred way to write it down. And now if I need an exact answer, then I can just type it into my calculator. And I can do 1/2 or I can do 0.5. So let's go and type in 0.5 times the log. And my calculator does have that option. So it'll be base 3 of 7.5 plus 3. So it'll be 3.92. So therefore it'll be 3.92 is an approximation. And now let's go and check your answer. So let's go through decimals. Actually, let's use the graphing calculator because we also want to get used to using your graphing calculator to. So in this case, I'm going to y equals, and I'll type in my first equation, 2x minus 6, move to the right so I can close my parentheses, minus 4. My second equation will be 11. Now if I graph it, let me adjust my window. So if I graph it, it looks something like this. And when you first graph it, usually probably have it, if you have it on a different window, you want to go under zoom and standard 6 so it fits in the standard window. But notice that the y-intercept, this is a horizontal line at 11. So I want to adjust my window and I'm going to change my y to about 15. And you can change this to -5, or leave as is. So that way you can see the entire graph. Now, do you remember how to find the intersection? So how can I find out where they intersect? I'm going to go under calculate, and then we'll go on intersect, number 5. It says first curve, press enter. Second curve, the right one, press enter. Guess, I will say yes. So therefore, notice that your x value for the intersection matches our answer. Example number 4. Go and copy it down, and we'll start once you are ready. Go and pause it. So for this problem, this is something that you're going to encounter in calculus. You have 3 terms, and if you notice, they both have an e, but they don't have the same exponent. Now, if they have the same exponent, then I can just add the coefficient. But in this case, I cannot add them. So we're going to do something interesting. We are going to rewrite this as e to the power of x squared. So is that equivalent? Yeah, that is the same, correct? 2 times x is 2x. Minus 7 e to the x power plus 12. And now what we're going to do, we are going to do a replacement. We are going to let u equals e to the x power. So therefore, instead of e to the x, we're going to replace it with u. squared minus 7. Instead of e to the x will be replaced with u plus 12. And now we can factor this out. Now we can solve this equation. And once we have our solutions, we're going to replace it back with e to the x power. So it's a trinomial. I'm going to factor it out. Factors of u squared will be u and u. Factors of 12 will be 7. So it'll be 4 and 3, and the both should be negative. And now because they're multiplying and they equal to 0, I know that my zero property tells me that u minus 4 equal to 0 or u minus 3 equals to 0. Move the 4 to the right becomes a positive. Move the 3 to the right becomes a positive. Those are not the values. Those are the values for u. But now we're going to replace. We're going to let e to the x power equals 4. And we're going to do the same thing with this equation. E to the x power, we're going to replace it with 3. And now we can solve it. Opposite way base is a log base e, which is the natural log on the left and on the right. And the same thing here. So therefore I end up with x equals the natural log of 4, or x equals to the natural log of 3. Now, sometimes I'll ask you to write down an exact answer. Sometimes we do need to go back and switch it to an approximation. So let's do that here. The natural log of 4 is x is approximately 1.39, or the natural log of 3, that'll be 1.198, so that will make it into a 10. So therefore, x is approximately 1.10. Now, can you check the answer either on your graphing calculator or on decimals, whichever you prefer. For this one, I'm going to do it on decimals. It'll be a little faster just to be able to find the graph. So I'm going to get rid of my equations. So f of x equals e to the power of 2x, and that's it, e, minus 7 e to the power of x plus 12. And therefore, my solution is those two, which is correct. Do you agree? Let me go back into my home, and there we can see the whole graph. So this one's also very nice because you can drag it around, and then you can see the x-intercepts are your solutions, or if you want, you can also place g of x equal to 0, which is the same thing, correct? Example number 5. So now let's go into a little more challenging problems, because the others were easy, right? They're just that. If it's dividing, you add. If it's dividing, you multiply. If it's adding, you subtract. If there's a log, you take the base. If there's a base, you take the log. Now, what should I do in this case? So write down, and then we can start once you are ready. You can pause it. So therefore, in this case, I need to get rid of the bases. There's no other numbers on the left or on the right. So opposite of log is a base. So therefore, I'll take the log on the left and the log on the right. But we do have a problem. The problem that we have is that here the base is 2. Over here is 3. So it can't, if I go into the log, you need to take the same base on both sides. So we're just going to take the natural log, the base 10, and we're going to end up with the log base 10 of 2 to the power of 3x plus 1 the log base 10 of 3 to the power of 4 minus x. And of course you can say, well, DS, how does that help? You don't want to get rid of the log, because otherwise if you get rid of the log, you're going to end up with what you had before. But our power rule tells me that I can move this as a coefficient. So therefore, I'm going to end up with 3x plus 1 as a coefficient for the log of 2. And same thing here, 4 minus x log of 3. The same way that whenever we had the log of x squared, that we were able to move the coefficient, the exponent as a coefficient. So we're doing the same thing. Now we are going to use the distributive property to multiply it out. So I end up with 3x times the log of 2 will be 3x log of 2. 1 times the log of 2 will be plus log of 2. Let's do the same thing here. Multiply the 4 and the negative x. So that'll be 4 log of 3 minus x times log of 3 will be negative x log of 3. And now I have x's here. This term has an x, that one has an x. So I'm going to move anything that has an x to the left if it does not have an x to the right. So it'll be 3x log of 2. That's a negative. We can say positive x log of 3. 4 log of 3. Move this to the right, becomes a negative log of 2. And now, what should I do? I cannot combine like terms, but we've done something similar before. What should I do on this side? Go and pause it, think about it, and then once you decide, we can continue. Correct. In this case, we can, since they both have an x, I can actually factor out the x, and then what's left behind? 3 log of 2 log of 3. That's the same, right? If you distribute, you end up with the same expression. And now I just need to be able to divide. That's multiply, so I want to divide, so I end up with x equals 4 log of 3 minus log of 2 over 3 log of 2 plus log of 3. This will be an exact answer. And I can actually rewrite it. I can also condense it. So if you notice, I have a minus in between. So if I have 2 logs, I can condense it into 1. And same thing here. I have an addition. I have 2 logs. So let's go through a process if we can actually simplify a little further. So I'll place this as my exponent. So it'll be the log of 3 to the 4th power minus log of 2. But then it's going to get messy. I mean, I can continue doing it, but I'm going to leave it as that. Because that way, 3 to the 4th power will be 81. And if you have a minus, it'll be a division. So I end up with the log of 81 divided by 2 over, and I'll do the same thing here, but now it'll be a multiplication with the log. This becomes 2 to the 3rd power, which will be 8. And because it's a plus, I can actually multiply, so it gives me 24. Now I'll have to type that into the calculator, so it doesn't really help to simplify it. So I'm just going to type it in as this, which will make it a little bit easier. But you should end up with the same expression. Let me use my fraction bar since I have it. And if you have your fraction bar in your ACTs, you probably want to use it. You want to be able to take, on your ACTs, you want to take a calculator that will do fraction bars, because that will save you time and you have to deal with the parentheses over and over again. If I can type today. So therefore, it'll be 1.16. Now let me see if I did this correctly. If I did this correctly, then if I type this in, then I want to do a log. 81 divided by 2 is 40.5. Correct? And I can even do the log of 40.5 over the log of 24. Then I can change it to x is equal to change of base log base 24 of 40.5. And if you type that in, that should still give you the same answer. So just in case you see it in a different form, you know. But for my purpose, for my homework, you can just leave it as this. You don't have to go through the whole condensing of your answer, because most of the time you have to use it and you have to approximate. Now, I want you guys to take the time to see if you can graph it and find the intersection. And you can use your calculator or Desmos, whichever you prefer. You got it? Go and pause it. So in this case, I'm going to use my graphing calculator. Let me clear both. So it'll be 2 to the power of 3x plus 1 and 3 to the power of 4 minus x. And graph it. So we're going to graph y2, then y3. It's coming somewhere. So therefore my intersection is a little higher. So I'm going to go and zoom, and I'm going to change my y to maybe 25. And now I can see the intersection. Hopefully that will give me, if you did through Desmos, you'll know that's a little faster. Let me go a little higher. Window, we go to 35 so I can see it. Slow. The T84 plus C is very slow, not sure why. And now I can find my intersection. So second, calculate, number 5. First curve, enter. Second curve, enter. And it gives me an intersection. So notice that that is the correct answer. Example number 6. So notice that all of the problems that we've been working on, example 3, 4, and 5, they all have been exponential functions. So we didn't need to check for extraneous solutions. But now in example number 6, we are working with logs. So therefore, we might end up with extraneous solutions, so therefore we have to make double check. So go and pause it, and we'll start once you are ready. So take the time to copy example number 6, and we'll start once you are ready. Go and pause it. So I need to solve for x. I need to get rid of the 4, the 3, the 2, and the ln, correct? What should I do first? Correct. So minus 4 on both sides. Next, I should divide by 3, correct? Ln of 2x equals 6 divided by 3 will give me 2. What should be the next step? Now, remember that whenever you see this expression, the 2x ideally should be in parentheses, but we don't always write them down. So I can't get rid of the 2 yet. I need to get rid of the log, the natural log. So therefore, to get rid of ln, I'm going to do a base on both sides. This is log base e, so therefore I'm going to take a big base on both sides. We're going to exponentiate both sides to a base e. And that will cancel each other out. since they're the inverse operation, we have 2x equals e to the second power. And now we can divide by 2 on both sides, so therefore x equals e squared over 2. If I need an exact answer, this will be my exact answer. If I need to approximate it, then I can just use a graphing calculator, and I can use my fraction bar on my graphing calculator, and I'm going to press E, which is right over here. You can barely see it, on top of the, right below ln. So it'll be to the second power, so it'll be 2.7 times 2.7, which is 7.29, I believe, and then divide by 2. So 3.69 is an approximation. The next number is a 4, so that one doesn't get right up to 70. And now let's use Desmos to graph this. I will go into Desmos, check your answer, see what you get, and then we can compare our answers. See if it matches the answer that we have. Go and graph it. Let's see. You got it? So f of x equals 4 plus 3 ln of 2x. And I prefer to place it in parentheses. I kind of know that that's correct. Notice the graph did not change. And g of x will be 10. So therefore the intersection matches our answer. And remember, we're only looking at the x value. Sometimes some of the problems that you guys will get in the homework might be greater than, so you can just do an interval, or less than, and you can do an interval as well. But for now, let's continue to example B. Now in example B, we have two logs. Log base 3 of x and 5 log base 3 of x squared. Now if those two expressions were the same, then we can just add 1 log plus 5 logs will be 6 logs. But because they're different, they're not like terms. We cannot add them. So what to do? So we're going to go back to the properties of logs that we learned, that we saw last time. And we want to be able to condense this expression, just like you guys did on your homework. But before, now remember that when we used to condense them, we used to move this 5 to the right. And that is proper. But instead, what I'm going to do, I'm actually going to move as a coefficient. So the 2 times 5 will be 10. And now, so we tended to condense them, and I'm actually changing my mind. Now I can add them, right? Because like we talked about, if there was a square here, but other cases we get rid of the square and move it as a coefficient. Those two expressions are equivalent, and now we can add them. We have log base 3 of x and log base 3 of x. So 1 log base 3 of x plus 10 log base 3 of x will give me 11 log base 3 of x. And now I can divide by 11 on both sides, so I end up with the log base 3 of x is equal to 9 divided by 11. And how can I get rid of the log? I want to take a base. Then we cancel each other out, so therefore x equals 3 to the power of 9 over 11. Now this is not the only way to solve it. There's other ways that will still give you the right answer. Now let's go back. Let's make an approximation. Use your calculator. So on your answers, you should have an exact answer, just like we have here. And then we'll talk about the answer in a second. To the power, I need a fraction bar. So it'll be 9 over 11. If you're not able to do this on your calculator, one of the things that you want to do, you want to be able to do 9 divided by 11. Then you're going to take 3 to the power of your answer. And it should give you the same answer. But you don't want to be able to approximate this here. Just use your answer so that we have an exact answer. Or more, not an exact, but more accurate answer. And I can go through decimals and check it. But for now, what we want to talk about is that sometimes you're going to end up with an extraneous solution. And that's going to happen whenever we take the log. We cannot take the log of a negative number. So the only thing you have to think, if I plug in 3.69 in here, will that be positive, 0, or negative? It's positive, so therefore that is correct. Now, for this one, if I take 246 and I plug in here, that'll be log basically over a positive number, so it's fine. It cannot be 0, you cannot take the log of a 0, and you cannot take the log of a negative number. How about over here? Yeah, if I square 2.46, it will still give me a positive number, so therefore this answer is correct. So that's how we're going to make sure that they're not extraneous solutions. Example number 7. Go and copy it down and we can solve it together. So now we have two logs and there's a plus in between. They're not the same log, so we can't combine like terms. So what we're going to do now, we're going to have to condense both logs into one. There's a plus in between, so both logs are going to become 1. And we'll have, what should I do with those two terms? I should multiply x multiplied by x minus 9. Now I can get rid of the log. Opposite of a log is a base. So the base is 10, so I'm going to exponentiate both sides to the power of 10, or to the base of 10. That cancels out, so therefore I end up x times x. Let me just rewrite it. 10 to the first power is just 10. Simplify this out. X squared minus 9x equals to 10. And now we can solve it. So let's make it equal to 0. And now we can factor, complete the square, quadratic formula. So in this case, if we can't factor it, I'm going to have to use the quadratic formula because we have an odd number. It gets a little messy otherwise. When you SAT and you SBAC, you'll have to complete the square with the odd number in between. That will make sure that you guys get your perfect scores that you want and your high scores on your SBAC, which should be perfect as well. Factors of x squared will be x and x. Factors of 10 will be 10 and 1 and 1 negative, 1 positive. So therefore x equal to 10 or x equal to negative 1. So now I need to check for extraneous solutions. If I plug in a 10, that's fine, right? I can take the log of a 10. How about if I plug in a 10 here? 10 minus 1 is, 10 minus 9 is 1, so it's fine. How about if I plug in a negative 1? Can I take the log of a negative number? No. Cannot take the log of a negative number. So now, let's graph it. Do you want to use the graphing calculator or decimals? Decimals will be easier, right? Now, some of the graphs that we are covering, we never graphed this type of function. When we have, well, we kind of did, but we didn't. Log of x plus log. We usually just have one log when we graph it. And where is it? That is a question. Oh, there we go. So there's a log over here. So now I'm going to graph the second one, which will be y equal to 1, or g of x equal to 1. So therefore my intersection, it's only 1, which is 10. Notice that at negative 1, there's no intersection here. Because of the log, the graph of a log, the domain is now real numbers. And that's when we encounter extraneous solutions. Letter B. So we have two logs, we have three logs, but we have two logs on the left hand side that we want to condense them into one. So therefore both natural logs are going to become 1. And notice there's a minus in between. This one's positive, If you have a minus, we know that it's going to be a fraction. And this one will stay the same. So this log is positive, so therefore goes on the numerator. This log is negative, goes on the denominator. And now our one-to-one property tells me that if I have two logs, this one should be equal to each other. Or if you want, you can say, no, I want to take the base e on both sides. That cancels and that cancels. Either way works fine. So we have 2x plus 1 over x minus 4 equals x. So go ahead and solve it, see what you get, and we can compare answers. Go and pause it. So let's see. What did you get? What will be my next step? My next step is to multiply both sides by x minus 4, correct? Or you can cross multiply if you want, whichever you prefer. You can place 1 underneath and cross multiply. That cancels out, so I end up with 2x plus 1 equals x squared minus 4x. I have an x squared, so I'm going to make it equal to 0. So I have 0 equals, move this to the right, becomes a negative. So I end up with x squared minus 6x minus 1. And now, can I factor? I don't think it's factors. X and x, 1 and 1, that won't factor out. Complete the square or quadratic formula. Well, in this case, this is even. There's no leading coefficient that's even, so I'm going to complete the square. Let me rewrite it. I'm going to place my equal sign over here. I'm going to move my 1 to the right. End up with x squared minus 6x. I'm going to leave some space and move the 1 to the right, becomes a 1, and leave some space. One number should go here. Correct. Plus 9. Half of negative 6 is negative 3. Square gives me plus 9. So therefore, this will be x minus 3, or x minus 3 squared equals to 10. Take the square root on both sides, so x minus 3 equals square root of 10, but let me not forget my plus or minus. So therefore, x equals 3 plus or minus square root of 10. And now I have two answers. X equals 3 plus the square root of 10, or x equal to 3 minus the square root of 10. Now, I need to double check to make sure that whenever I plug this in, I will not be taking the natural log of a negative number, or 0. Now 3.1 is, well, square root of 10 is about 3.1, right? But we can actually do it on the calculator. So if you don't have a calculator, then you just have to estimate it. And you might have to do that for the test. That should be about 6.1. So x, this is the exact answer. We don't know if both of them are correct. One of them might be an extraneous solution. This will be an approximation. And I can just do second and then go back. Minus. So negative 0.6. So that's it. If I plug in a 6 here, so let's think about 6, that's 12, 13, so I can take the log of 13. If I plug in a 6, 6 minus 4 is 2, so therefore I can take the natural log of 2, so that one's fine. This one, I cannot take, let's try here, negative and negative, that'll give me negative 4.16. Then that's not correct. So we only have one answer, which is B. And we can actually take the time to check it. So notice that I'm really emphasizing for you to be able to know how to check. It's just a very quick process, or unless you prefer to do it manually. I think this is much easier. And we actually allows us to be able to tackle some of the concepts. The only intersection is here, which is correct. Example number 8. That's not it. Example number 8. So we'll take the time to copy it down. We saw something similar to this problem when we did compound interest. So take the time to copy it down, but now we are able to solve. Well, before we were not able to solve. Now we are able to solve this. We have those tools now. Go and pause it. So you have deposited $1,000 in an account that pays 6.25 interest, compounded continuously. So when you see compounded continuously, so every time I say the word continuously, I always think of the E, even though there's no E in there. So do you remember your formula? What's it? U amount, P, E, R, T, PERT. Where A is your initial amount, or A is your your P is your initial amount. A is your current amount. So you deposit $1,000. E, R is the rate, which is 0.0625. How long will it take for your money to double? T. Now, for your money to double, we want the A to be twice as much. So therefore, we want it to be 2,000. And now we can solve it. Before we didn't have the tools to solve it, but now we do. So what should I do first? I need to leave the T by itself. So I need to get rid of the decimal, the base E, and the 1,000. Correct. Divide by 1,000 on both sides. So divide by 1,000, divide by 1,000. So that gives you 2 equals E 0.0625. Next step is to get rid of the E. So we're going to take the ln on both sides. So it gives me, let me switch sides. 0.0625t equal to the natural log of 2. Divide. So therefore t is equal to natural log of 2 divided by 0.60625. And now I'm going to use my calculator since I need a how many years. So it's going to take 11 years. Approximately 11.09. So we can say it will take 11 years for your money to double. So let's continue with example number 9. Go and paste it and read through it or copy it down and read through it, highlight the key things, and we'll start once you're ready. Go and pause it. So at this point you've read it. And does it look familiar? On a campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spread of the virus is modeled by the following equation, where T is time and Y is the total number of students infected after T days. The college will cancel classes when 40% of the students are infected. Now, if you notice, we did this on section 6.4, and we did it the exact same problem, but once we actually got to solving, we graphed it and found the intersection to be able to find the number of days. Because before, we did not have the tools to be able to solve this type of equation, but now we do. So let's go and set up the equation. The college will cancel classes when 40% of the students, 40% or more of the students are infected. There are 5,000 students. So if I multiply by 40%, which is 0.4, then there'll be 2,000 students, correct? So therefore, I'll let y equal to 2,000. And let me copy my equation. 5,000. T is greater or equal to 0 due to the time. We don't want to go back in time, so we don't want it to be negative. So 1 plus 4999 e the negative 0.8 t. And now we can solve for t. So pause it, take the time to solve for t, see what you get, and then we can compare our answers. Go and pause it. We got it. So what will be the first step? Correct. I should just multiply it by 1 plus 4999e to the negative 0.8t on both sides. Now we're very tempted to use the distributive property to multiply this out. I know that this cancels, so therefore I end up with 1 plus 4. I'm not going to multiply it out because you'll see what we're going to do instead. So therefore, instead of multiplying it out, I'm just going to divide it. Now you can multiply it out and you'll get the same answer. But in this case, I'm just going to divide by 2000 on both sides, on the right, on the left, and on the right. So therefore that cancels, and I end up with 1 plus 4999 e is 0.8t equal to, the zeros cancels, so 5 divided by 2 is 2.5. And now I can solve for t, get rid of the 1, the 4999, get rid of the e, get rid of the negative 0.8. So minus 1 on both sides, so I end up with minus 1 gives me 1.5, divided by 499, so it gives me e to the power of negative 0.8t equal to 1.5 over 4. Correct? How do I get rid of the base e? I take the log on both sides, log base e or the natural log. That cancels, so therefore I end up with negative 0.8 t equals 1.5 over 4999, and I'm taking the ln of the entire fraction. And I'm going to divide by negative 0.08. So therefore my exact answer will be t is equal to the natural log 1.5 over 4999 over negative 0.8t. Oh, not t, right? Just we divide by, we don't need t in there. Now, if I did it correctly, when I type it in, then I should end up with 10 days. I'm just going to use my fraction bar that I have in here, makes it a little easier. So let's see, fraction bar, natural log. Let me see if I can do another fraction bar, and I can. 1.5 divided by 499. Close my parentheses, negative 0.8, and it gives me the correct answer. So therefore, after 10 days, so t is approximately 10.14. So after 10 days, the college will cancel classes. So that will conclude the lesson for today. Have a great day, and I'll see you guys next time.